Now, we're going to take up one more problem. A beam of problem number 24. A beam, capital ABCD, is simply supported at B and C, 4.5 meters apart. And overhanging parts, capital AB and CD, are 1.5 meters and 2 meters long, respectively. So, 1.5 meters and 2 meters long, respectively. The beam carries a UDL of 10 kilonewton meter, 10 kilonewton per meter between A and C. So between A and C, it is 10 kilonewton per meter. There is a clockwise couple of 60 kilonewton meter at D. So there is a clockwise couple at 60 kilonewton meter at D. Draw the BMD and SFD and mark the salient values on it. So first we need to find out the support reactions. The support reactions is taking the moments about the point B. So we will going to get it as, so clockwise couple will be counterclockwise couple, therefore which will be RCV into 4.5, then plus 10 into 1.5 into 1.5 by 2 will be equal to 10 into 4.5 into 4.5 by 2 plus 60. So on simplification, RCV, we will going to get it as 33.33 kilonewton here. And then also we know the sum of the vertical reactions acting upwards will be equal to the sum of the vertical reaction which is acting downwards. So that will be equal to 10 into 6. So 10 into 6, therefore RBV will be equal to 60 minus 33.33, we are going to get it as 26.67 kilonewton. So RBV will be equal to 26.67 kilonewton. Now we are going to try to analyze this problem by taking the stepwise now. So when you are considering between A and B with UDL of 10 kilonewton per meter and 1.5 meters distance, and without considering the reaction at the vertical point, at the vertical reaction at B. So when you are considering that, SF at A will be equal to 0, SF at B will be equal to minus 10, that is minus 10 into 1.5 will be equal to minus 15 kilonewton. So here we are going to get from A, which is 0, and at point B, without considering the vertical reaction, it will be minus 15 kilonewton. Now similarly, when you're considering the bending moment at the point A will be equal to 0, and the bending moment at the point B will be equal to minus 10 into 1.5 into 1.5 by 2, which will be equal to minus 11.25 kilonewton meter. So the bending moment varies parabolically. So here the bending moment varies from 0 to minus 11.25 kilonewton meter parabolically. Now when you're considering the second reaction, so here if you are considering this, so we have RBV will be 26.67 kilonewton, which is acting upwards, and also you have an UDL from B to C. So we are considering from B to C without considering the vertical reaction at RCV, which is 33.33 kilonewton, which we are not considered here. So without considering that, we will see how it will going to works out. SF at B will be equal to minus 10 into 1.5 plus 26.67, which is SF at B, which will be equal to plus 11.67 kilonewton. Then SF just on the left hand side of C now. So it will going to be or SF at C without considering the vertical reaction. So therefore, it will be equal to plus 11.67 minus 10 into 4.5 will be equal to minus 33 kilonewton. So therefore, one thing what happens at minus 15 kilonewton, because due to the vertical reaction at B, it goes from negative to the positive at 11.67 kilonewton. Then without considering the vertical reaction, because only due to the UDL, so it drops down from 11.67 kilonewton to minus 33.3 kilonewton. Similarly, bending moment at the point C will be equal to minus 10 into 6 by 2 plus 26.67 into 4.5. On simplification, you will going to get it as minus 60 kilonewton meter. So here, so we got from the bending moment diagram, here this is minus 11.25 and here it is minus 60 kilonewton meter. But SF is changing its sign from positive to negative here. Therefore, you cannot draw from here to here directly, because when the SF changes its sign from the positive to negative, so the bending moment will be maximum at that particular point. So that we need to find out. So that is the reason why we cannot draw the bending moment diagram now at this juncture. Now similarly, once you are considering this, So now we will going to consider the reaction at reaction at C, and also then the couple which is at the point D, which is 60 kilonewton meter clockwise. So SF just is on the right hand side of C will be equal to minus 33.33. Since you are considering the vertical reaction here, which is acting upwards, which is 33.33, so it becomes 0. So SF at D will also be 0. So because we will not going to consider the couple at the point D for the shear force. So as there is no other load between C and D, therefore SF at D will become 0. So this is the plot between the shear force diagram. So once you get this, what will going to be the bending moment diagram? The bending moment diagram will be, so here minus 10 into 6 by 2 plus 2 meters plus 26.67 into 6 plus 26.67 plus 33 into 2 plus 33 into 2 will give you this value, that is bending moment at the point D without considering the couple. So that will be minus 60 kilonewton meter. So that is here minus 10 into 6 by 2 plus 2. Then we have 26.67 into 6.5. Then 33 into 2. So both are positive because both the loads are acting upwards. So this is by considering without considering the couple now. So you will going to get bending moment at this point D will be equal to 26 minus 60 kilonewton meter, that is at the point D. Because due to the couple, you will going to get minus 60 minus 60, it becomes 0 at this point. So due to the clockwise couple at the right. Now, once you get this, so where you are going to get the maximum bending moment? So the maximum bending moment you are going to get where the SF changes its sign. So SF changes its sign at the point E from positive to negative. At that point, you will going to get the maximum bending moment. So SF changes its sign from B and E, that is at the point B and also at the point E. Hence, the bending moment is maximum at these points. So we have let E be at a distance x meters from B. So once you are considering that, SF at E will be equal to 0, which will be 26.67 minus 10 into x. So x will be equal to, so here minus 10 into 1.5. So minus 10 into 1.5, that is because due to UDL, plus 26.67 minus 10 into x, because SF at this distance from x meters from A. So naturally we need to consider the portion which is onto the left hand side of the section. So minus 10 into 1.5 because it is acting downwards, and 26.67 into x, 26.67 which is upward reaction which is positive. Then between these two, that is the UDL with respect to that section which is minus 10 into x. So therefore, the value of x will be equal to 1.167 meters from B. So that is what x will be equal to 1.167 meters from B. So what will going to be the bending moment at the point E now? BM at E will be equal to, so you have, so once you are considering that, so it is at a distance of x meters. So minus 10 into x is 1.167 from this support B, but we have the distance as 2.667 because 1.167 plus 1.5 will going to be 2.667. So that is the total distance. So minus 10 into 2.667 into 2.667 by 2. So that is for the total distance, plus 26.67 into 1.167. So that is the distance with respect to this support. So once you are substituting that, the value will be equal to minus 4.44 kilonewton meter. So here the maximum bending moment will going to occur at this point, which is minus 4.44 kilonewton meter. So since from between B and C it becomes a UDL, therefore you have a parabolic curve. So that is the reason why we are joining between these 3 points by means of a parabolic curve. So this is how you will be able to analyze both the shear force and also the bending moment diagram, and this will going to be the final solution. Thank you.